Welcome back everybody. In this video, I'm going to walk you over on solving ladder problem following the entire umpire process. Okay, as usually, I copied down the entire problem statement into my IDE. So let's read the question problem. For a given integer n less than or equal 9, print a ladder of n steps. The kth step consists of the integers from 1 to k without spaces between them. To do that, you can use the set and end argument for the function print. For example, for n equals 3, your program must print this pattern. Okay. So what I'm going to do is first, I'm going to increase this number up to 4. So this would be 1, 2, 3, 4. Okay. So first, let me write over here what's given. Okay. So the input is n. Okay. A number. So n basically, all right, and n less than or equals 9. Okay. So it's good to write all of those information. Okay. So, and then the output basically output is this pattern. Okay. So we need to basically print it. Okay. So the restrictions already here, n is between 1 and 9. Okay. Inclusive. All right. And also we have more hints like printing horizontally. So you can use this n parameter in print function. Okay. So you can also take those into account as well. Okay. All right. So what I'm going to do is I'm going to write this output like this. Okay. So, okay. So I'm going to write it over here. Okay. So first I'm going to like create 2 columns. Okay. So this step is iteration I. Okay. So iteration 1. So the output is 1. Iteration 2, 1, 2. Okay. Iteration 3, 1, 2, 3. The whole idea is to find a pattern that we can apply. Okay. And then 1, 2, 3, 4. Okay. So notice we are printing these numbers. Okay. So when iteration 1, we print 1. Okay. So just print 1. And here we print 1 and 2. Here we print 1, 2, and 3. Okay. So here we print 1, 2, 3, and 4. Okay. So now we can see the clear pattern over here, right? When I equals 1, print I times 1 time. Okay. When I equals 2, print 2 times 1 and 2. When I equals 3, print 1, 2, 3 times. Okay. So there's a clear connection between how many times do we print and this I. Okay. So that's the basically pattern that we want to follow here. Okay. So when I equals 4, we print 4 times. Okay. So it seems like this is this one way of iteration goes down like this, and each iteration step another iteration goes horizontally down like this by printing that many times. Okay. So that means if this iteration is I and if this iteration is J, basically we're going to basically print um, J is going to be I times. So up to I, we're going to print uh, horizontally. Okay. All right. So let's write our plan over here. Okay. All right. So okay. So I'm going to clear this one now. Maybe I can keep it. Let me try to keep it. Okay. So I'm going to scroll up over here. Okay. So plan number one, step number one. So the match is basically, so this seems to be 2x2 for loop. Okay. So I forgot which one, but I'm generally right. Okay. 2x2 for loop. Okay. So one is all the way out, one is from top to bottom, and printing in a single line is the second for loop, okay, inner for loop. Okay. So the plan, so let me get this to the top. Okay. So number one is input n. Okay. So then basically two, well, we start our for loop, right? 4. Okay. So for numbers, okay, from, well, 1, right? So we start always with 1, right? So 1 to n. Okay. And then we are inside now for loop. Okay. So 2.1. Okay. Excuse me. And then we print. Okay. So print. Well, sorry about that. So we need the second for loop. 4. Okay. So again, numbers. I'm going to write like verse 2 from. Okay. So now again, we are printing like in here, like 1 and 2. So again, from 1 to how many times? It's basically this numbers time. Okay. So, okay. All right. So, and then that's it. So we are inside now that for loop. So that is going to be 2.1. Okay. All right. So I'm going to scroll up a little bit. Okay. 2.1. So, all right. 2.1 basically printing. So print numbers 2. Okay. So that's it. So that's our plan. Okay. So let's convert this plan to an implementation. Okay. So we came up with the plan. So let's write our implementation. So, okay. For, well, we need to collect the input, right? So that's our first step. So n, I'm going to take n equals int input. Okay. I usually write a prompt over here. Okay. So it makes it, otherwise it's just empty space blinking in your Python prompt. Okay. All right. So write it. Okay. Enter number. Okay. All right. So next step, first for loop. Okay. So for, okay, numbers. We'll write I. So it's the iteration, right? For I in, okay. So now we need a range, right? So it's here. So this is a range from 1 to n. So range, okay, 1 to n, okay. And then right? So the second for loop, 4, right? So let me take as J, okay? All right. So J in I, right? So basically range I, right? So we need to basically get a range and 1 to I. So ranges are exclusive. So we need to add actually +1 over here for both of these. Okay. And then, okay. So print J. And let's try it like this and see what comes out. Okay. So we are not done yet. So I'm going to try out. Okay. Let me just be clear like this. And let's run it. Okay. All right. So I'm going to give, let's try 4. All right. So didn't work. Right. So let's see. It's printed like in a vertical column. Okay. So it's obvious, right? So we have to use the n parameter. So n equals nothing. Okay. So basically empty string. So that means basically we're going to print in a single line. So the default n parameter for print is actually new line character. That's why every time we print, the thing that we're going to print get printed in a new line like this. Okay. So run it again. All right. So again for 4. Well, still we are still not there. Okay. So let's analyze what's happening over here. So you can see the first number got printed in the first iteration. In the second iteration, we see 1, 2 got printed. And in the second iteration, we see 1, 2, 3 got printed. And in the fourth, 1, 2, 3, 4. So our algorithm correct and it works. So there's few adjustment that we need to do. Okay. So if you can see that one of these iteration, right? So let's say the last one, 1, 2, let's say the third one, 1, 2, 3. Okay. So we are printing that 1, 2, 3 over here, right? So in this for loop. So what happens is basically every time we print in the same line because we have the same print command, right? So what we have to do is over here, basically, once we come out of this inner for loop, we need to go to the next line, new line, right? So it's basically, so we have to make a line break over here, over here, over here, right? So that means we need to add the print with default new line character, which is just the print command, okay? So this at the end here is not new line character, but here it's new line character. So let's try now. Okay. All right. So again for 4. Yep. So we got the answer, right? So we got 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Okay. And we can try now with 9 and we get the same result. Okay. So, all right. So this is a classic 2 for loop problem, but let's try to now evaluate our result. Okay, see that we did it with using 2 for loops. Okay, so usually a rule of thumb is if you get to solve something using 2 nested for loop, always ask yourself, can I do it in a single for loop? Okay, so chances that you may be um, improving the speed of your program. So there's a good chance for that. Okay, so let's try to evaluate that. Okay, so let's try to analyze to improve now. So that's basically the last process. Okay, so we're gonna evaluate. So this one basically it seems like there's 2 for loops. So what I was thinking is maybe can I do it in a single for loop? Okay, so let's try that analysis process. Okay, so what I'm going to do is I'm going to clear this now. Okay, I'm going to restart my drawing. Okay, so I'm going to redraw the whole thing. So let me get rid of this. Oh, right here. All right. So I have now enough empty space. So I'm going to start over here. Okay. So what I'm going to do is I'm going to redraw the steps. Okay. So, okay, iteration. Okay. So and I might need a lot of space over here. So 1, 2, 3, and 4. Okay. So, all right. Okay. So over here, so we have 1 and 1. I'm going to spread apart a little bit. 1, 2, 1, 2, and 3, and 1, 2, 3, 4. Okay. So let's try to attack this problem in a different approach. Okay. So again, the idea is finding a pattern. Okay. So let's now, if we carefully look, we have this set of this 1, 2, 3, 4. Oops. This 1, 2, 3, 4. Right. And that is also going along with this 1, 2, 3, 4. Okay. So this is I over here. Okay. So this is I. This last number is also I. What else can we see? So if we can break this each number, so now my idea is to basically find the relation between current number to the previous. Okay. So I'm going to write this 12 like this. So we have 1. So we start always with 1. Okay. But 12. Okay. See that I can, if I can somehow separate this 2, I can write it like, okay, 10 plus 2. Okay. Now I'm going to write this one. I'm going to do the same thing to this one. So I'm going to separate 3. So I'm going to write 120 plus 3. And here on 1230 plus 4. Okay. Now, how do we make the current value of iteration into the next one? So here's what my thinking. Okay. So if you take a good look over here, I can write this one again as 1 time 10. Okay. So now this 1 is right over here. Okay. Let's see if that pattern continue. Okay. So I can write this 12 times 10. And well, I have 12 over here. This whole thing is 12, right? So basically now it continues. Okay. So when I go to the next one, 1, 2, 3 times 10. Right. So plus 1, plus 2, plus 3, plus 4. You have that. Okay. So basically, this is right here. The sum is this, right? Okay. So the if I take this as the current step, okay. So this value, the whole value is basically previous value times 10 plus 4. Okay. So if I write it like that, basically, if I write this as the total, this one, okay. All right. So the next one is going to be basically right, this total times 10 plus 3. Okay. So we can basically break it into 2 steps, right? So how do we get the current value? Basically, we get the previous value multiplied by 10. So let me mark it like this. Okay. So current value equals, right, previous, so in this case, if this is the current value, okay, previous value total 12, okay, so let me say like this is 123 equals, okay, 12 times 10 plus 3, okay, so so let me scroll down a little bit. All right, okay, so well, I'm gonna go up here, okay, kind of loose. All right, so right here, okay, so current value 123 equals 120, so basically 12 times 10 plus 3, okay, so that means if we generalize this, so current value equals previous times 10 plus 3. It's always the case, okay, so we need to basically, if this is the generalization, so basically if we write it in I, basically we can write it like this, so previous value, okay, so plus I, okay, all right, so how do we get the previous value? So we need to basically, it's an accumulation problem, okay, so let's write our new algorithm based on this, okay, so I'm gonna go get the mouse again. All right, so we still have the input, those stuff, so number one input n, okay, so number two, right, so again we iterate for I in between 1 to n, okay, all right, so then we are inside the for loop 2.1, okay, so what we have to do is basically we need to initialize a sum, okay, so this is this sum basically, okay, right here, okay, so it's basically previous sum, so that means we see basically we need one more step before that, so it's step 2, so sum equals 0, so it's initialization, so I'm going to write like init sum, okay, and then we need to create that sum, okay, so what is that sum? Is sum basically well, update sum, okay, the update process is basically get the previous value, okay, with basically, let me write it like this, previous, all right, sorry about the, let me go down, I think I can go down now, yeah, all right, so right here, okay, so previous sum times 10, right, see that over here, times 10, all right, and then next step is we need to add the current I value, okay, so this should be, sorry, this should be 3.1, 3.2, so basically again update sum, okay, with adding I, okay, so we need to add I actually, okay, all right, sorry about the confusion between the drawing and the typing. Okay, so that's it. So then basically we need to print that sum. Okay, so it's the single for loop. Okay, so 3.3 step is print. So instead of printing one digit at a time, what we did was we calculated a total value. That's what we did. Okay, print sum. Okay. All right. So let's write this into our implementation. Okay. So excuse me. So again, int n equals. I'm going to copy that over here. So I can copy both of these lines. Okay. All right. So excuse me. Excuse me. All right. So now we need to basically, okay, so here say sum equals 0. Okay. So let's go check our update sum with previous sum. So sum star equals, so this is a multiplication accumulation 10. And then the next step, okay, another update. So this one plus equals, we add I, all right? So it's right here, okay? We add I, okay? And it's this right here, okay? In the step 2, we add 2, right? So that's I. All right, that's it. So we're gonna basically at the end, we are going to print, well, print sum, okay? All right, so I'm gonna block the code above and rerun this. Okay, right again, okay. So let's do it for 4. There you go. We got the same pattern only by executing single for loop. Okay. So there you have it, complete umpire process to solve the ladder problem.